Hello, in this video we're continuing our discussion of section 6.5 on approximate integration. Specifically in this lecture we're focusing on Simpson's rule. So we've already done one example with Simpson's rule where we applied it to a problem where we just had some data points. Now we are applying it to an actual integral. We're going to use Simpson's rule with n equals 4 to approximate the integral from 1 to 2 of 1 over x. And in this problem, we're asked what specific value are we approximating here? So this example illustrates another really nice use of approximate integration in that it will allow us to approximate a specific value that might not be very easy to determine on our own. So if we have n equals 4 and we're talking about the integral from 1 to 2, this means that a equals 1 and b equals 2. So then delta x is b minus a over n, which is 2 minus 1 over 4, or 1/4. So then x sub 0 is going to be 1, x1 is going to be 5/4, x2 is going to be 6/4 or 3/2, x3 is 7/4, and x4 is 2. Then the integral from 1 to 2 of 1 over x dx will be approximately equal to delta x over 3 f of x0 plus 4 f of x1 plus 2 f of x2 plus 4 f of x3 plus f of x4. That is Simpson's rule. So we have 1/4 divided by 3. Our function is 1 over x. So we are going to have 1 over 1, which will give us a 1. Then we'll have plus 4 times 1 over 5/4, or 4/5. Then we'll have plus 2 times 2/3 plus 4 times 4/7 plus 1/2. And we can do a little bit of arithmetic there. If you keep it exact, your fractions get kind of ugly, but it should be 1,747 over 2,520. But it is perfectly fine for you to use a calculator to get that value. You can also get an approximate decimal value to be 0.6934. So that is what Simpson's rule tells us for the integral from 1 to 2 of 1 over x dx is approximately equal to. Now to figure out what specific value we're approximating, notice that we can actually evaluate this integral from 1 to 2 of 1 over x dx. The antiderivative of 1 over x is the natural log absolute value of x. We're going to evaluate that at 1 and 2. So we get the natural log of 2 minus the natural log of 1, and the natural log of 1 is 0. So this means that the exact value for the integral is the natural log of 2. Well, if we combine the two answers that we got, then this means that the natural log of 2 is approximately equal to 0.6934. And there is another nice use of numerical integration, or approximate integration, is that if you are approximating an integral that you can actually evaluate analytically, you might be able to use it to approximate or get a pretty accurate decimal approximation for an irrational number, a number that you can't really represent any easier.